Okay, let's continue. And here is another hyperparameter that is called coefficient 0, and it controls how much your model is influenced by the high degree polynomials versus the low degree polynomials. Well, think about that. If we are doing the polynomial S3, for example, so we are only using the feature A and B as two original features. So if when we are adding the new polynomial features up to degree to 3, and then we still have the original features a and b, and then we have degree 2 polynomial features a squared, b squared, and a multiplied by b, and we have degree 3 polynomial features like a cubed, b cubed, a squared, b squared, a, right? So among those features, and we have low degree polynomial features like a and b, and we have high degree polynomial features like a cubed or a squared b, for example. And how do we balance those features? How much weight or how much the low degree polynomial features can influence the model compared with the high degree polynomial features, and that will be the question we have to answer. And we can control that by using another hyperparameter coefficient 0. Okay, so let's create another SVM model, and we still use the poly as the kernel, and then we use the degree as a 10 and coefficient as a 1 and the C as 5. And by the way, what is a C? We talked about that last time. So C controls how wide the margin can be. So if we want to do a small c, and then the margin will be wider, and we allow more margin violations, right? Okay, so we specify all those three hyperparameters, and then we build a model. And another time we want to do another coefficient is 100. So we try two different coefficient, 1 and 100, right? And then if we want to plot the descent boundary, and this is what we got. So it seems that for the coefficient as 100, and we are influenced a little bit more with the higher degree polynomials, and that also makes the descent boundary kind of weird. And well, I'm highlighting this part. So for this part, the blue area here doesn't make too much sense to me, and the reason is we are influenced by the high coefficient. Okay, so the next question you may ask is, well, we have the C, we have the coefficient 0, and we also have the degree of the polynomial. So there are three hyperparameters now. And when we create a SVM, how do we know what are the good hyperparameters? And the answer is usually that's very hard. Well, for the degree of polynomials, well, remember the rule of thumb is we don't want to try a very high number. But how about the C? How about the C? Well, for the C, usually it depends on how beautiful the data set is. But considering we are adding even more higher degree polynomials, and well, it's hard for us to do the exploratory data analysis to get the idea on how good the dataset is. And plus, for the coefficient 0, and what should that be? It is really a hard problem. So to solve that, what we have to do is we have to do a grid search. So for a grid search, well, the idea is very straightforward. We want to try all the possible combinations. Okay, so it is like that the rod of a robotic vacuum. So to vacuum a living room, for example, it just goes through all the possible passes on the vertical side and then on the horizontal side to make sure that it vacuums all the area of this room. So for the grid search, we kind of do the same thing. So to do a grid search, so the first we have to define what is our search space. So in this case, I created a dictionary, right? So that is a dictionary. So the first key is the C, the second one is degree, and then the coefficient, and then the kernel. So those are the keys in this dictionary. And the values for each key, well, they are the list. So for each of the lists, we specify what are the values we want to try. So remember, when you are creating this kind of dictionary for this to define your search space, you don't want to go too far. So like say for the C, from point 1 to 1 to 10 to 100, and that's reasonable. If you want to do point 0.1, point 0.2, point 0.3, point 0.4, and then you add 100 different values of the C, and that should be too many. And when we are doing the grid search, and the code will take a lot of time to run. So to do this part of the code, I do have to shrink my search space a little bit so that it is runnable. And after that, you want to do a grid search CV, and then you want to run a in the grid search CV, you specify what is the machine learning model you are trying, and then you also send the parameter grid or the search space. Okay, so and after that you run the grid.fit with the x and y, and it will just try all the possible combinations of the different hyperparameters. Say for this one, that is the c is 0.1, coefficient is 0.1, and the degree is 5, and then c and coefficient, they are the same, and then we try the degree as 10. So it just exhaustively try all the different combinations, and as you can see, there are really a lot. So well, this cell definitely takes some time to run, and after that we have we can do the grid.best params. So it will give me the best combination of the parameters. So we have the c as a 0.1, so that is very small c. So we are going to have a very wide margin, and the coefficient, that is a 10. So that's not too large, not too small. Probably I'm going to be happy with that. And then the degree is 5. So for degree is 5, and that is the lowest possible. So probably I will try a few lower degrees, but degree as 5, I would be happy with that. So the next question is, do we want to stop our searching here? So there are well, to answer that question, do we want to do another round of the searching? There are 2 points I want to make. The number one is, well, you need to understand what are those hyperparameters mean. So C as point 1, and you should know C defines the width of the margin and the number of the margin violations we are going to allow, right? So C is 0.1, so that is a small enough number. Do you want the C to be even smaller? If you try even smaller C, your performance might be even better, but do you want to do that? Well, you should know that if you are doing a very small C, and then we may have a under-fitting model, and probably that C is small enough. Okay, and then for degree is 5. Do you want to try even smaller degrees? And my answer is probably we can try even smaller degrees, like 2, 3, or 4. So we may want to try that. Okay, and the second point I want to make is, well, you need to grab your best estimator, and then you want to use your best estimator to do a prediction for you. Okay, so you can use your best find your best estimator, or you can just use the grid, and then the grid by default it will make the prediction with the best estimator, and then this is the result I got. So for this result, I'm definitely going to be happy with that. So to answer this question, should we stop the grid search here, or do we want to do another round of the search? Well, by seeing the performance of my best estimator, and I will say, okay, I think I'm happy with the result, and I'm okay by stopping here. Okay, so the next video we are gonna start to do an exercise, and I will see you in the next video.